So this is the fourth video lecture of class 10 chapter 12 electricity, and in today's video lecture we are going to learn section 12.2 electric potential and potential difference. So these are the topic which is already covered in my previous video lecture, so if you want to watch, click the I button. So now let's see what is electric potential and potential difference. So the very first question arises in our mind is, what makes the electric charge to flow? So to answer this question, let us consider the analogy of flow of water. So charges do not flow in a copper wire by themselves, as just water in a perfectly horizontal tube does not flow. So as you can see here, copper wire, but there is no flow of charge, and same here, there is a tube but there is no flow of water. So why this happen? To answer it, let us consider this activity, that if one end of the tube is connected to the tank of water kept at higher level such that there is a pressure difference between two ends of the tube. Now we are taking this tube and connecting it with the tank kept at higher level and in another tank which is kept at lower level than the first tank. And now what happens? Here the pressure difference is created between these two ends of the tube, and this pressure is due to fluid pressure, and due to this fluid pressure the water will flow from this tank to this tank. But for the flow of charge in a conducting metallic wire, the gravity of course has no role to play. So if you take the conducting wire and you put on an inclination, so there will be flow of current? No, of course there will be not, because gravity doesn't play a role in the flow of electrons inside a conductor. So the question arises that how electrons move in the conductor if there is a difference of electric pressure, as we had seen that in the case of water, so there was a pressure difference created due to the fluid pressure, and due to that pressure the flow of water has been done. Same way, for the flow of electron inside a conductor, there should be some sort of difference between the end of the conductor, and this pressure difference required is electric pressure, and we call this electric pressure as potential difference along the conductor. So the another question arises that how this potential difference is created between the end of the conductor. So this potential difference is created or produced by the battery or one or more electric cells. Now let us understand the phenomena of how this pressure is created. So as we connect the battery here, so battery have two terminals, one positive and another negative, and this positive terminal attracts electrons of the negative charge towards itself. So here the negative charges of electrons get attracted to the positive terminal of the battery, and same vice versa here, this negative terminal of the battery repel the negative charge electrons. So due to that the difference is created here. So the attraction will be high here and the repulsion will be low here. So here there will be high potential and here there will be low potential, and once the difference is created there will be the flow of the electrons, and once this electron flows there will be flow of electricity or current. So this is how electrons flows inside a conductor with the help of batteries. Hope it is clear. So another question arises that how this potential difference is created on the terminals of the battery. So the chemical action within the cell generate potential difference across the terminals of the cell even when no current is drawn from it. So here chemical reaction plays an important role for creating potential difference along the terminals of the battery. And when the cell is connected to the conducting circuit element, the potential difference set the charge is in motion in a conductor and produces electric current, as I told you. And in order to maintain this current in a given electric circuit, cell has to expand its chemical energy stored in it. So this is how electricity is flown in the conductor. It is very interesting thing, and hope it is clear to everyone. Now let us define potential difference. So we define the electric potential difference between 2 points in an electric circuit carrying some current as the work done to move a unit charge from one point to another. Now let us understand this scenario. If there is a car, and if this car want to reach its destination here, what it have to do? It have to do some mechanical work, and for the movement of this car from here to here, some mechanical work is required and time. So same as for the flow of electron inside a conductor, work and charge of the conductor is required. So the work done to move one unit charge from one point to another is known as electric potential. So here let us consider this electron. This electron have charge Q, as I told you in my previous video lecture. And to move this electron from here to here, the work done is required. And the work done is required for what? To move this electron of charge Q, and it is only known as your potential difference. So, and we denote potential difference as V, and mathematically we define as work done required to move charge Q from one point to another is our potential difference V. Hence, it is clear to everyone. And the SI unit of electric potential is volt, capital V, named after Alessandro Volta, an Italian physicist. 1 volt. Now this is also one important definition of 1 volt. So 1 volt is a potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move charge of 1 coulomb from one point to another. So as everyone know that the SI unit of work is joule and SI unit of charge is coulomb. So 1 joule work required to move 1 coulomb charge is known as your 1 volt, and the SI unit of volt is joule per coulomb, or you can write like this also, joule per coulomb. The potential difference is measured by the means of an instrument called voltmeter. So if you want to find potential difference between two ends of a conductor, you have to make use of voltmeter. It will give you the exact potential difference between two ends of the conductor. The voltmeter is always connected in a parallel across the points between which the potential difference is to be measured. So you have to remember this thing, that we have to connect our voltmeter in parallel connection between 2 points in which we have to measure the potential difference. Now let us understand one example given in your textbook, that is example 12.2, that how much charge is work done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volts. So here we are given with the charge which we have to move and the difference between the 2 points in which this 2 coulomb charge is moved. And now here we have to find work required to move this 2 coulomb charge. So few seconds ago I told you that formula of volt is work by coulomb. So here we know value of volt and value of coulomb, and we have to find the work. So we can rewrite this equation as work is equal to volt into coulomb, and after substituting the values we will get work in a joules, that is 24 joules. Hope it is clear. And the topic which will be covered in next video lecture is circuit diagram. Notes are uploaded on the bloggers page of Time to Cram. So visit the bloggers page to download the notes, and the link of the bloggers is given in the description box. So check the description box, get the link and download the notes. And if you find this video helpful and informative, then like it and do share it with your friends and classmates. And yet you had not subscribed to our channel Time to Cram, then subscribe it. And don't forget to hit the bell icon so that you will get latest notification and update when new video is uploaded. That's all for today's video lecture. Thank you.